All right, everyone, this is experiment 9, which is types of reactions, okay? We have a bunch of demos to look at, and we also have the many different experiments to look at types of reactions, okay? Here we go. So this is demo number 1, okay? We're gonna take some magnesium metal, and we're going to add it with oxygen, okay? Which just means we're gonna burn it. Okay, so we turn on our Bunsen burner. Turn it down a little bit. There we go. And this is listed in your demo as a synthesis reaction because I'm taking magnesium metal and I'm adding it to oxygen to make magnesium oxide. True, it's also combustion because I have fire. Fire needs oxygen to survive. It's both types of reactions, okay? Here's magnesium metal plus the oxygen in the air. Okay, so we'll look at it one more time, okay? Magnesium metal plus oxygen in the air, and I get magnesium oxide, which if you can see, this is kind of like white powdery stuff. Definitely not the magnesium piece. Grab an even bigger one that I started out with, okay? So we'll look at one more of these. All right, exciting, okay? There's our first demo. If any of you are interested in like military stuff or play video games at all, any kind of flash bang, typically the flash has some kind of magnesium in it because it burns very bright. Flash bang, neat, chemistry applied. Okay. On to demo number 2. We are looking at calcium carbonate decomposing. Okay, so what we do is we take some calcium carbonate. I'm gonna take a nice little scoop of it, put it into our test tube here. And then we're gonna decompose it. So in order for it to break down, we're gonna break it down with some heat. So we're going to turn back on our Bunsen burner. Maybe. Striker's stuck. This is not good. There we go. And we turn it down. I'm gonna grab a different striker. And don't move your fire, kids. Okay? We will heat up our calcium carbonate. You can hear it. I don't know if you can hear it through the phone, but you can hear there's like a little crackling. Something is definitely happening. You can see that the little granules of calcium carbonate are changing, okay? You can definitely see condensation within the test tube. And then to check and see what's happening with this decomposition reaction, I should be getting some carbon dioxide forming out of this reaction. So what I'm gonna do is I'm gonna light this on fire, and the fire should go out if I put it inside the test tube because it should be filled with carbon dioxide, okay? Ooh, exciting, right? Because fire needs oxygen to survive, and since it's making carbon dioxide, fire goes out immediately, okay? All right, we are now getting into single replacement reactions, okay? So we have this nice copper wire that's twisted in a little curly Q. Okay, so we have copper wire plus silver nitrate in this beautiful bottle, okay? So I'm gonna pour silver nitrate into the test tube with copper wire. I'm gonna watch what's gonna happen. Go all the way almost to the top. I'll leave a little bit of space because I don't want it to overflow. Okay, just a good lab suggestion. If you are pouring something like what I was just doing, make sure your other hand that you're not holding onto the test tube or something underneath where you're pouring. Because if I slipped, I would, you know, pour on myself, okay? All right, so right away you can see the color of the copper is changing. We see that, okay? The color went from the copper kind of bronzy color to this darker color, which is exciting. Okay, I'm gonna try and zoom in so you guys can see. Some pretty cool stuff is happening. Okay, so this was the copper wire, and you can now see there are these little crystals that are forming around the copper wire. You can even see those tiny little kind of dark flakes that are falling around in the solution. And the longer it goes, the more and more crystals that form. Okay, so I'll come back in a minute to show you what it looks like in 1 minute, so you don't have to actually watch the whole thing. So it started out looking like that copper wire, and now it's like it's almost fuzzy. Okay, so about 5 minutes have gone by since I filmed last, and look at what this beautiful thing looks like. There are crystals everywhere. It's fabulous. Chemistry is so cool. And mind you, this whole thing, this giant fuzzy thing, all started out at that clear, thin wire. And now it looks like this. Gotta love it. So I'm going to move this off to the side so we can keep going with our demos. But you can really start to see the crystals now. And I'm gonna zoom in again in like 20 minutes or so you can really see what's going on and what it looks like. Okay, our next demo is we have zinc metal, and we're adding it with hydrochloric acid, okay? And to understand what's going to happen here, we'll look at the actual reaction, okay? Crouch down here. So zinc plus hydrochloric acid, okay? I have a single and a couple, all right? Got a home wrecker and a couple. So the zinc's gonna swoop in, kick hydrogen out of the way. So now I have zinc with a 2+ charge bonding with chlorine with a 1-. So this will be ZnCl2. And now hydrogen is all by its lonesome, womp womp, H2, okay? Because hydrogen is one of those diatomics, okay? And then you would of course balance 2 chlorines, 2 hydrogens, 2 chlorines, 2 hydrogens, okay? I am going to see if this reaction is actually happening by testing to see if there's hydrogen gas that's being formed, okay? One of the super cool things about when you light hydrogen gas is you hear this very distinct, like high-pitched pop, okay? So after we do this experiment, when I add the zinc to the hydrochloric acid, we are going to see if we hear that pop when I light the splint and put the splint in whatever gas is formed above here, okay? All right. Maybe. Okay. So we're gonna add some zinc. Okay, nice little amount. Right in there. And we are adding 6 molar hydrochloric acid. So much more concentrated than what we worked with in lab the other day. 6 molar HCl. Always make sure you check your labels because a clear solution looks like any other clear solution. Make sure you know what you're working with, okay? All right, so we're gonna add some hydrochloric acid. And you can hear bubbles and you can see bubbles. Hopefully you can see that in the video. Okay. Get our Bunsen burner on just to light our splint. And let's listen to see if we hear that pop. We do. Hydrogen gas. Awesome. All right, we are on to our double replacement reactions. So we have potassium iodide, okay, 0.1 molar potassium iodide that we are going to mix with 0.1 molar of lead 2 nitrate, okay? So we have our potassium iodide that we're adding first. And we are going to add lead 2 nitrate to it. Okay, and this is like wife swap, right? The anions flip-flop. So let's see what happens. Ooh, okay. So we clearly make a precipitate, we make a solid. So this is what lead 2 iodide would look like, because that's going to be the solid that forms in here, which I guess is one of the answers to your lab, but here you go, exciting, okay? All right, next in our double replacements, we are going to have 1 molar of sulfuric acid mixed with, 0.1 molar of sulfuric acid mixed with 0.1 molar of sodium hydroxide, okay? And what we're going to do is, yes, this is a hot plate, but we're not actually using the heat part for it. We are going to use a magnetic stir bar, okay, inside our beaker, and we are going to turn on the stir function so that when my solution actually gets in there, it's going to stir up the solution. Cool, okay? Don't need it on ridiculously fast right now. Okay. There we go. So we are going to start with sulfuric acid, okay? So we're gonna add some acid here. All right, and what we're going to do is we're gonna actually add some phenolphthalein, or PTH, okay? It's an indicator, which just means it's a color changer. It will indicate what pH the solution is. So phenolphthalein turns pink if a solution turns basic. Okay, so if the solution is acidic, I shouldn't see any color in it. So we're gonna put 1, 2, 3 drops. And I see no color, which makes sense because sulfuric acid is an acid. Okay, so I don't see any color, it's nice and clear. If I'm going to add NaOH, sodium hydroxide, which is a base, I should see a color change in PTH, okay, when I add enough sodium hydroxide into this solution. I should see that switch from it being acidic from sulfuric acid to it being basic when I add enough base. Okay, so if I add a little bit of base, still nothing, right? Add a little more. You can kind of see it turn pink and then turn right back to clear. Add a little more. Turns pink, turns back clear. If you add enough base, the solution itself will turn basic. And you can tell that from PTH, your indicator. Okay, so I made my solution basic instead of acidic. Basic. All right, and this beautiful double replacement reaction, I'm gonna have some 6 molar hydrochloric acid, and I'm going to add some sodium carbonate into it, okay? Okay, so we should see some kind of reaction. So there's my 6 molar HCl, and I'm gonna add some sodium carbonate here. Ready, set? Okay, we see bubbles right away. Very exciting. They die down if I add a little more. See if it reacts more. Yep. Okay, so I'm creating some kind of gas. I see bubbles. Right, that's one of the clearest ways to know that a chemical reaction is taking place. You see bubbles, you know some kind of reaction's happening. This is a double replacement reaction. Very exciting. You can even try and get really crazy with it. Big ol' scoop. Exciting. Okay. It's just like elementary school trying to make your volcano explode. Yay, science. Here's an update for anyone who's made it this long in the video. Look at that. Look at that. That's our copper wire. It's getting crazy. So that's what it looks like right now. It's mossy. I love it. Okay, and our last demo is a combustion reaction, although technically we did already see one, right? That magnesium plus oxygen is also a combustion one, but this one, we have ethanol, which is a liquid at room temperature, okay? So we have ethanol and we're gonna light it on fire. So we're gonna add some ethanol to this evaporating dish. And then it's on a heating plate, so we're gonna warm it up a little bit. Just making sure it's working. Don't touch hot plates. Do as I say, not as I do, right? Here we go. Okay, so it's warming up. And then we light it on fire. And what do you know? It burns. Very exciting. So we have ethanol, which is carbons, hydrogens, and oxygens. And we have oxygen in the air, and it's burning. So if you've ever been to a fancy restaurant and they light your dessert on fire or something, this is what they do. Ooh, pretty. Fire! We'll just let that burn out. And for all of you who made it this long and this much in lab, this is what our beautiful copper to silver replacement reaction is looking like. Isn't that great? Look at those crystals. It's been about an hour of this reacting. Pretty dang cool. Let's see if you can see it on the other side too.